Bismillahirrahmanirrahim. Today's topic is again the mechanistic analysis, but um, this is a mechanistic analysis for flexible pavement. The same software will be used, and that is the KENPAVE. And for KENPAVE, the module KENLAYER will be used for damage analysis. So what I have done is have taken the same truck. We had to analyze a 4-axle truck 1.2-22, having an initial factor of 10.84. And for that, they have designed up with the following pavement section. Asphalt surface, it's 3.5 inch. It means bearing course is a 2 inch and 1.5 is an aggregate base. And the crush aggregate base 4 inches. And the CBR of soil having 6 inches. The pavement is initially designed for 20 years. This is the same truck, and it's unlike in KENPAVE, we don't need to analyze these dimensions. We just have to just see it's a tandem axle. What we need to understand that what are the distance between the axles and the distance between the 12 tire. Otherwise, all the other data is unimportant, or it's not very important like that we have for a KENPAVE. Now the solution, we start with weight load calculation. As if we understand that in Pakistani trucks, such type of truck is allowed 39.5 tons gross weight, and that's equivalent to 87 per kilo pound. So accordingly, we are interested in load on each axle. So that's 14% of the load will become on the steering axle, the first axle. The middle axle or the drive axle, 30% of the load will be shared, and the load on the rear axle or the trailer axle will be 49.117 kilopound. The tire pressure is 120 psi on the first axle truck tires. The other has 140 psi. The next thing is what you need to do is to calculate the contact radius. That's important. The contact radius, if it's a single tire, that contact radius is simply the square root of the load on each of the tire and divided by the pi and the tire pressure. So that can calculate to be 4. And then 4 inches. And for the dual tire, the combined tire pressure is calculated as A. So that's how this load on the dual and all those calculations, tire pressure and pi. So for the remaining axle, middle and rear axle, the tire pressure was calculated from this formula. SG is the distance between the dual that is 14 inch, as mentioned here. So we got the value of 9 and 9. It has to be emphasized here that the distance between dual tire, SD here, or YW in the software, it's 14 inches, and the distance between axle is 48 inches. So let's move on. Unlike KENPAVE or KENSLAB, we have to have these loading data. It start with the load group number. So if we have a single axle with dual tire, that is coded as 0. So that's the first axle we have a single axle having single tire, that's why 0. The contact radius we have calculated, we know the contact pressure. And since it's a single axle, there will be single axle with single tire, there will be no YW and XW. And we need the response, that's why we write NRS1. Load number group number 2 is the middle axle. It has got uh, single axle with dual tire, that's why it is being coded as 1. Again, the contact rate is 9. That contact pressure is 140 psi, and since it's a dual tire, so the distance between dual tire is uh, YW in the software. That's why it's 0 and 1 like that. And the third axle, we know it's a tandem axle. So again, tandem axle with dual tire is 2. So we'll have 9 contact radius. Its contact pressure 140. The distance between the dual tire is 14 and the axle is 48 inch, and that's NR required. We are doing it. So once you know this thing, what we are going to, we have calculated this thing in Excel, then we'll go and input the value in the CANPAVE software. So we'll start with here in which what we do, we'll say okay, and again we'll say just close this window so that you don't have to bother about anything. And then, so this is it. So we'll start with layer input, and here because this is where this is what we call KENLAYER, and that's what in the software we are going to use. So in this thing, when we say we have to shoot layer input, we'll have an option to open the old file, and okay, so we'll say exit, and then so we'll say layer input, we'll go file, we'll go old file, and that I've already done this thing. So WB40 KENLAYER 1, I'll open it. Generally there is nothing different. We are evaluating the linear mass material. We are doing damage analysis, that is 1. The number of load group is 3 because we're taking only one truck, and that has actually got 3 type of axles. The number of layers are 4. 2 layers of asphalt surface, 1 of crush aggregate base course, and the 4th layer is the subgrade. And that's there is nothing we will change. And when it says OK, now the second thing is the layer. Here it will ask us. So we say it's 2 inches, and we were given 3.5. So we'll say 1.5 here, 4-inch crush aggregate base, and that's OK for us. Then we go for the moduli. Normally, 350,000 or 400,000 is as for asphalt bearing course. 3,000, 50,000 is for asphaltic base course. We have 30,000, and I assume that for CBR6 it's around 800,500 psi is the value of the subgrade. Okay, we'll say okay. Then the next thing is the load 0, 1, 2. Contact radius vehicle 499. Contact pressure 140. XW 0W and R is 1. This contact pressure again. So we have already calculated in Excel sheet. So that's why we just have to input this data. Say okay. And then there is nothing we have to do the damage analysis. we have to use these values. So just sometimes the default value is 0. We just have to put it 1. That's it. Otherwise, all these coefficient value are has been the default values, and we will be using it. And so is for that as well. Some when you will have open a new file, then NLTC has to change to 1. That's it. And that's okay. The volume of traffic is again the total number of load repetition that we have calculated in Excel as well. The same 79132. So we say okay, then okay, we get out of this window, we'll say just for save as, we say this is one for video. So that's, I'm writing it as a video, then save, then I will say exit, and then I'll run KENLAYER. Okay. So what you need to do is once again go to the editor first, and for editor, we open that file. It was about this one, video. Open, and then find the values is 48.91. It's fair enough. If we want an economical section, we'll have to do it once more. Otherwise, it's fair enough. The section is adequate enough for this truck design. However, we can try one more. We'll just use the thickness and see what happens. So we go for layer input. We again open the old file. That is the video file. Open. And then we'll change only the thickness. Instead of 2, we say, let's see, it's 1.25. And it's okay. We'll save it. We'll exit it. And we'll run it again. So once again, everything is done. I will go to editor. I will open the file. Again, that's video file. And so it's 5.32. So it means that we will stick to that 1.45, 1.5 asphaltic base course. So that's a very simple problem. It's not, I have not solved it as a complicated problem, but you can add different load. We can have 12 different load at a time. It will analyze it likely. So thank you very much. I hope that you have understood the concept of mechanistic analysis using software. Take care. And Allah Hafiz.